couple different ways to represent vectors, not only geometrically, but we're going to talk about what the unit vector is. We're also going to talk about magnitude and direction, and just kind of represent them algebraically. So initially we have right here, so the vector V, we can do the net notation where that is a position vector. V1, V2 is basically where the end point is. Same thing with W1, W2. We know how to add them geometrically. It's always helpful to know an algebra kind of method. It is exactly what you would think. So if I get two vectors, you kind of think of the V1 and W1 as the X component. So you're just going to add the X components. You're going to add the Y components. That's going to be the sum. If you're subtracting, subtract the components. Now that's not multiplying vectors. Okay, that is a scalar multiple. So you just multiply the constant times both pieces for there. All right, so for this first one, where are we at? All right, yep, on the top. Now you don't have this grid, and you don't need this, the coordinate system. Don't worry about that. I'm just going to show something here in a second. But for V plus W, so we got 2, 3 plus negative 4, 1. 2 plus negative 4 is negative 2. 3 plus 1 is 4. All right, I mean, that's all there is to it. Now, I just want to make sure that you see how that matches up with the geometry part. So up here is 2, 3. Let's see here. There's the vector 2, 3. There's the vector negative 4, 1. All right, let's add them geometrically. I'm going to do like we did yesterday. Let's see. So I'm going to move that here. And now my sum has to be from my initial point to the terminal point. Well, you clearly can see it's negative 2, 4. Obviously, if you do it geometrically, you get a better visual picture. Algebraically, you're going to understand this at the same place. So for negative 2V, you just take negative 2 times 2, 3, and you're going to get negative 4, negative 6. It's going to be going in the opposite direction. It's going to be twice as long. That's all that's going to happen there. C, 2V minus W, so 2 times 2, 3 minus W, which is, what is that, negative 4, 1. And I get 4, 6 minus negative 4, 1. 4 minus negative 4 should be positive 8. 6 minus 1. Did I do that right? 7. Is that right? That's what you're looking at. I think I did
6
something.
minus 1.
Should be 5. 6 minus 1. I put 7. 2V minus. So that should be 5. Now am I right? All right, now we're right. All right, what's that notation mean for D? Magnitude. Okay, that's the distance. So now that's the same as what is C. So we're going to find D, magnitude of 2V minus W. Oh, what do we got over here? What movie is that, Cole? You don't know. I don't either. Square root, what is it? Square root of 89? So 64 plus 25 should be 89 for that. So now we got the algebra way. If it's a position vector, just add them like normal, subtract them like normal. Okay, for that. Now this is probably typically how most books will present, especially, and I can't remember how you did it in physics, how you represented, but it's called the IJ method. So it's the same, basically the same as what we did here. This is how it works. I is a unit vector. It would be basically the vector that starts at 0, 0, and ends at 1, 0. So it goes that direction, length of 1. J would be 0, 1. It would go up 1 unit. Those are called the standard unit vectors. What we can do is we can write any vector in terms of the unit vectors. It's very simple. Don't make it complicated. 3, 4 is simply 3i plus 4j. That's all you got. Basically, you're taking 3 times the length of that unit vector, which will give you the 3. And then 4 times the length of the unit vector. That's all you got to do, 3i plus 4j. And if you got a negative, just make it negative 2i plus 6j. And then I got 4i minus 8j. No, there's no like commas in between. It's just like an expression. It's a binomial. So negative 2i plus 6j is the same as the vector negative 2, 6. 4i minus 8j is the same as the vector 4, negative 8. Okay. All right, same idea here. Let u be 4i minus 5j. Let v be negative 2i plus 3j. Go ahead, let's go ahead and find u minus v. And really all you're going to do is just like with 2 binomials, 4i minus 5j minus negative 2i plus 3j. We're going to get 4 minus negative 2, which is 6i. Negative 5 minus 3 is going to give me negative 8. Okay, 6i minus 8j. That is the same as, vector 6, negative 8. Similarly written like that. All right, so take a look at what's 3u plus 2v. Okay, 3u plus 2v. So I got 3 times 4i minus 5j plus 2 times negative 2i plus 3j. And then that gives me, hold on, 12i minus 15j plus negative 4i plus 6j. And what do I end up with? 12 minus 4 is 8i. And then negative 15 plus 6 is going to give me negative 9 minus 9j. Okay, so you get 8i minus 9j. All right, now that third one there, they want the magnitude of 2u minus v. Go ahead and see what you get. Find 2u minus v first, then find the magnitude. All right, I got 10i minus 13j, at least for the first part. Nathan, we're good. All right, did you get the magnitude, Nathan?
No.
Do you know how to get the magnitude? No? All right, magnitude. Remember, the magnitude of v is simply v1 square root of v1 squared plus v2 squared. So the magnitude of 2u minus v is the square root of 10 squared plus negative 13 squared. For that, and Tony, what'd you end up with?
10u minus 13j.
Did you get the
260 square root of 269?
There you go. Square root of 269. Okay, you get 100 plus 169. Square root of 269. All right, so there's your magnitude of 2u minus v. All right, so now here's kind of where we're at. We have a vector here, so you could call it, I don't know, let me make it like 5, 3. Or you can write it as 5i plus 3j. The next way we can talk about it is in terms of its magnitude and its direction. This is where a lot of times, like in physics, they're going to pose it. You're going to represent initially vectors in terms of magnitude and direction, and give you the problem in terms of that. So let's see. Let me look at your notes. All right. So you basically got u or v, u, and w on there. V, I want to tell you, has a magnitude of 10. So whatever, if it's in inches, it's 10 inches. Whatever your units are. And it has a direction of 40 degrees. The direction is to measure the angle between the positive x-axis and the vector. Just like in a unit circle, you know, you got 40 degrees, you got 120 degrees, you got 210 degrees. You're always going off the positive x-axis. W has a magnitude of 4. Okay, in a direction of 200. U has a magnitude of 8 in a direction of 310. Okay. Now here's what we want to do is we know this one right here, V, has a magnitude of 10 in a direction of 40 degrees. How would I label it in terms of I and J? How could I figure out that? I need to figure out what that point is. Well, based upon what I got, I know this is 10. I know this angle is 40. How would I find those values, x and y? I need to know how far over to go and how far up to go. So I know it's magnitude of 10. I know it's a direction of 40. How would I find x? How would I find y? All right, Aaron, how would I find x?
You find x with cosine of 40 would equal x over 10. So cosine of 40 times 10.
Okay, cosine of 40 equals x over 10, so x equals 10 times cosine of 40. I agree with that. We'll just leave it like that. Sine of 40 equals y over 10. So y equals 10 times sine of 40. Let's just leave it like that. Basically what you've done is show me how you convert from magnitude and direction to basically either this IJ form or that vector form. So if you go to that next sheet, a vector V is going to be the same as the magnitude times the cosine of the angle with an I on it plus sine of the angle J. So that's another way to represent it. So that expresses a vector V in terms of magnitude and direction. So V is 10 times cosine 40I plus sine of 40J, because we said, now the 10 will distribute to both of those. W would be 4 times cosine of 200I plus sine of 200J. And then U would be 8 times cosine of 310. So now what we want to do is kind of work between the two forms. All right, I'm going to tell you this vector has a magnitude of 6 and it has an angle of 45. So that would be the one in quadrant 1. So go ahead and just draw it as best as you can. Draw as best as you can. So draw that one. Okay, we want to write it in IJ form. Now, and it's very simply, that would be, is it 5I plus 4J or whatever? That's kind of what we need to come up with. Well, we just said right here, we can take this vector and write it in terms of cosine I plus sine J. So do this here. So V, vector V, is going to be 6 times cosine of 45 degrees I plus sine of 45 degrees J. Okay, cosine of 45 degrees I plus sine of 45 degrees J. Now, if it's a unit circle angle, I want the exact values. So what's the cosine of 45? What's the sine of 45? We've been doing that for a long time now. So cosine of 45 is radical 2 over 2, and sine of 45 is also radical 2 over 2. So now V equals 6 times cosine of 45 is square root of 2 over 2 times I plus square root of 2 over 2 times J. Distribute the 6. So you get 3 square root of 2I plus 3 square root of 2J. Now it should make sense that both of them have to be positive because it's quadrant 1. So you gotta move to the right, you gotta move up. Be the same thing. All right, the second one is actually the one in quadrant 3. Let the length of that one be 8. Let the angle be 240 degrees. Okay, so now you're gonna have to estimate the length. Okay, and it's not gonna fit in a perfect spot. Let's figure out what it is in IJ form. So W, the vector W is gonna be 8 times cosine of 240I plus sine 240J. Now, what is cosine of 240 degrees? Okay, so you're thinking that it's going to be the short leg, so it's going to be negative 1/2 because it's in quadrant 3. So it's going to be negative 1/2 I plus negative square root of 3 over 2J. So in the end, we get negative 4I. And then what is that? Minus 4 square root of 3J for that. Now there is a third one. Okay, the third one is V. V is a length of 4, and it has an angle of 130 degrees. All right, is 130 degrees a unit circle angle? Nope, you're gonna have to use your calculator. You have to use your calculator and round to the nearest 100. So we got a vector with a length of magnitude of 4. Its angle is 130 degrees. We want to write it in this IJ form. So once we get it in the IJ form, it's a lot easier to add and subtract vectors together. So V equals 4 cosine of 130 degrees I plus sine of 130 degrees J. So the vector equals, I'm going to take an extra step. 4 cosine 130 I plus 4 times sine of 130 degrees J. Nearest 100. Nearest 100. Okay, Mackenzie, you got it?
Negative 2.57I plus 3.06J.
Okay, so I believe you, but 4 cosine 130. So you do that, negative 2.57. Okay, and it should make sense that's a negative. If you plug in the angle, it is going to give you the proper sign for the proper coordinate quadrant. So it gives you a negative. So it has to give me a positive for the next part, as long as we're doing everything right. And so 4 times sine of 130. Oops. And that gives me the 3.06. Okay, for that. All right, so that's given magnitude and direction and going to IJ form. Let's flip it around. Now, I know you don't have a grid and you don't necessarily need one, but U is the vector 2, 3. U is the vector 2, 3. What would be its magnitude? What would be its direction? Okay. Well, we do the magnitude like we always do. Magnitude would be the square root of 2 squared plus 3 squared. So the magnitude of u, square root of 13. All right, what's its direction? Or how am I going to find it?
I take the inverse tangent of 2 divided by 3.
Take the inverse tangent of what?
2 divided by 3.
I'm going to say 3 divided by 2.
Yes.
All right, you going to agree with me now?
Yeah.
This is really going to be a right triangle. If you take a look at that theta, we know that opposite side is 3. We know the adjacent side is 2. So that means theta is going to be the inverse tangent of 3 over 2 in that case here. And so inverse tangent of 3/2, inverse tangent 3 divided by 2 is 56.31 degrees. 56.31 degrees. So our magnitude, square root of 13, direction 56.31. So magnitude square root of 13 is fine. If they want it in a decimal as well, we can round it if need be. And then direction, we got no choice to have a decimal here. 56.31 degrees. All right, if it's in quadrant 1, it's a little bit easier. What you got to watch is if it's not in quadrant 1. So take a look at this one here. So put down the vector 5, -8. Okay, that's for that second one down there at the bottom. All right. Now you want to see where is it. You need to obviously know where is it located at. It's located in quadrant 4. All right, just give me a rough estimate. What is a rough estimate of its direction? Okay, just a rough estimate. So Tony, what would that be?
300.
300. It's got to be bigger than 270, so it's got to be around there. So around 300. All right, now go ahead and find the magnitude like normal. That's not going to change. So the magnitude of V is going to be the square root of 5 squared plus -8 squared, which gives us square root of 89. All right, now what you want to watch is your calculator is not going to give you back the direction like as an initial answer. It will never give you back an answer 300 degrees or even close to that. Here's what you got to do. I think this is the best way to do this is you still got to think, all right, I do have a right triangle. I would think this is your Y, this is your X. This will be your reference angle. So your reference angle is going to equal the inverse tangent. I'm always going to do the absolute value of Y over X. Okay, just take out the signs. Don't worry about the signs. Just make it everything positive. That will give you your reference angle. Then from there, you got to figure out using whichever quadrant you're in, what the final direction is. So my reference angle is going to be inverse tangent of the absolute value, which would be -8 over 5, which is going to become 8 over 5 when I type it in my calculator. All right, see what you get nearest 100. See what you get for that for the nearest 100. Faith Burns, what did you get?
57.99.
57.99. So what is the direction? The direction would be, in this case, 360 minus 50. Whoops. Hold on. 360 minus 57.99, which gives me, what is that, 301.01 or 302? 302. Ah, good guess there, Tony. 302.01. So you got to watch if it's not in quadrant 1, because that is not going to, your answer when you do the inverse tangent was always going to give you an answer between 0 and 90. And then you gotta use that as a reference angle. All right, like I said, I wanted to kind of work through this, give you some time in class here, to get some stuff done. You do not need graphics. You don't need graphics. That was just for the rolling them out yesterday. And I should probably get attendance.